This video is on logarithmic differentiation. Logarithmic differentiation is actually kind of a lot of fun. We're going to use it when the function is y equals some variable base to a variable exponent. Like, look at the first problem we're going to do. Y equals x to the x power. There's a variable in the base, there's a variable in the exponent. So that's the main time we're going to use it. Or it's also useful at times if you have a real messy product rule or quotient rule combination that you have to do. Sometimes logarithmic differentiation will actually simplify the problem. So, if we take a look at this, I have a variable in the exponent, and I need the variable not to be in the base and the exponent at the same time. So the way to move this exponent is to take the log of both sides of the equation, and then I can move that x. Okay, do you remember the rule? If I had natural log of 3 squared, I could move that 2 down in front, and that would equal 2 times natural log of 3. Using that rule, I need the log of x to the x, so I can move that power. You are allowed to take the natural log of both sides of an equation. It's the same as, well, not the same, but it's the same property of equations as, multiplying by 3 almost both sides, or adding 5 to both sides. I'm allowed to do it. So the natural log of y equals the natural log of x to the x power. And the benefit of that is that this power can move down in front. So the natural log of y equals x times the natural log of x. And I hope you can already see that everything here, I know the rules of taking the derivative. Now I'm going to take the derivative of both sides. I'm going to just write out here what I'm doing. The derivative of the left-hand side is going to equal the derivative of the right-hand side. So the derivative of the left-hand side, the derivative of natural log of y, this is like natural log of u. That's going to be 1 over u, or in this case 1 over y, times the derivative of y. I'm going to write it as y prime. On the right-hand side, the product rule. First term x times the derivative of the second term. Derivative of natural log of x is 1 over x, plus second term, natural log of x, times the derivative of the first, which is just 1. Okay, let's clean this up. I got 1 over y times y prime, nothing to do on the left yet. The right hand side, that becomes 1, so we just have 1 plus natural log of x. Now I need to solve for y prime. I need y prime by itself. Right now I have on the left hand side basically a divided by y. So I'm going to multiply both sides by y. And when I do that, on the left I simply have y prime, and on the right I have y times 1 plus natural log of x. What I want to do here is replace y with the original equation. So go back to the original equation and we'll just sub it in. So I get y prime equals x to the x power times 1 plus natural log of x. And that is my solution. Let's talk about the steps that we did to make this happen. And these were the steps you would follow for all logarithmic differentiations. First thing we did, take the log of both sides. Okay, you could use natural log or you can use log base 10. It doesn't really matter. Okay, the second thing we did, we moved the exponent down in front. That's the reason we're doing logarithmic differentiation, is so that we don't have a base that has a variable and an exponent that has a variable. Next step here, we took the derivative of both sides. I'm going to write that as differentiate both sides. Or differentiate the entire equation. Okay, once you do that differentiation work, down here, what do? We solved for y prime. And if you're starting with natural log of y on the left-hand side, which many of the problems will, not all of them, but many of them will, then you're going to end up, multiplying by y on both sides. That's going to be a technique to get there. Okay, once you've done that, then the last thing we did here, we took this y out. We're going to substitute to eliminate y in the final answer. We'll do some problems in the next video.